This video lecture is meant to help you understand density of a substance and the slope of that solid liquid line in a phase diagram. First of all, I want to draw your attention over here to this graphic, which is showing you water in the liquid phase and water in the solid phase. So you can see here in the solid phase, water molecules are actually further apart from one another than they are when they are in the liquid phase. And that's because these little stretchy little lines right here, these are those intermolecular attractive forces. Specifically in water, these are called hydrogen bonds. But this is the reason, because of these intermolecular attractive forces, this is the reason why solid water or ice is less dense than liquid water. And this is just to kind of give you the visual representation of what that looks like. All right, but as we said in class, this is highly unusual for most substances. The solid is more dense. Particles are packed tighter in the solid form than they are in the liquid form. And so we're going to see how this manifests itself in a phase diagram. All right, so the water phase diagram has the solid liquid line that tips back and to the right or back and to the left with a negative slope. And carbon dioxide has the solid liquid line that tips to the right with a positive slope. Okay, and we've got some reference lines on here that are going to help us understand or help us track our argument here, explaining why this density behaves the way it does. So let's go ahead and take a look down here at this explanation. The question is, what happens physically when you increase the pressure on something? The answer is, well, when you increase pressure on something, the molecules get closer together and the substance becomes more dense. So remember, as we talk through this, that the increase in pressure means the substance is going to become more dense. Okay? So if we're following a phase diagram along a line of increasing pressure and the substance changes form, the form at the higher pressure will be denser than the form at lower pressure. Okay, so let's take a look at what that means. So let's go ahead and take a look at the water diagram. For the water diagram, I'm going to pick this line that is denoted by point E, A, and G. And the reason for that, why I'm going to pick that line, is because it's a line of increasing pressure and it's going to go through all three phases. So gas to solid to liquid. Okay, those are marked here. This is a solid because it's at the lowest temperature. This is the liquid because it's generally at the higher temperature, and gases are down here at higher temperatures but lower pressures. So if we look at point E to point A to point G, we see that the pressure is increasing. But look what happens. As the pressure is increasing, so does the density. So gas is the least dense, right? And then solid is the next least dense, and then the most dense is liquid. So in this case, the liquid is more dense than the solid. Okay, now let's go ahead and take a look at carbon dioxide. We're going to choose a different line of to refer to. We're going to pick F and B and H because on those set of points, it is increasing pressure from F to B to H, and we're going to hit all three phases: gas to liquid to solid. Okay, so you can see here that increasing density, we are going to start with gas being the least dense, and then liquid being a little bit more dense, and then the solid being the most dense of all. Okay, so the conclusion you can draw from this is that this positive slope, solid to liquid line in a phase diagram, so it's tipping to the right, means that the solid is more dense than the liquid. A negative solid to liquid line here, as it is in the water, with a negative slope, means that the liquid is more dense than the solid. So this is all based on the premise that increasing pressure means increasing density. Hope this video helped, and check out the other videos that help explain phase diagrams.